You know, a conditional statement, by the way, can be written in a shorthand by writing this P arrow Q, where P and Q are both themselves little statements, and this can be read as if P, then Q. Sometimes read P implies Q, but we've been reading it as if P, then Q. And it turns out that armed with this conditional statement, we have three related conditional statements. One is called the converse, which just switches the roles of hypothesis and conclusion. And so we have if Q, then P. The inverse, which is not, this little sign here means not. So if not P, then not Q. And the contrapositive, where we switch the hypothesis and conclusion and inject a negative in front of each. So if not Q, then not P. Well, there are a lot of things to think about, and I want us to look at an example. Here's a conditional statement. I'm going to think of this as sort of if P, then Q, where the P is that an animal is a dog, and Q is it has 4 legs. And I want to now write out each of the corresponding converse, inverse, and contrapositive statements, and for each determine if in fact it's true. And if it's not true, let's provide a counterexample. So let's start off. So the statement is, if an animal is a dog, then it has 4 legs. What is the converse of that? Well, I'm going to switch the roles of hypothesis and conclusion. So if an animal has 4 legs, then the animal is a dog. Well, it turns out that that converse statement is false, because it turns out that a cat is an animal that has 4 legs and is not a dog. So that statement is false. What about the inverse? Well, the inverse says, if an animal is not a dog, then it does not have 4 legs. Well, that statement is also false, and a cat provides a counterexample, because notice that a cat is an animal that is not a dog, and yet a cat does have 4 legs. So therefore this statement, well, not this statement, but this statement would be false. And finally, the contrapositive would be to switch these roles and inject the word not. So if an animal does not have 4 legs, then the animal is not a dog. And it turns out that statement is true. Now, of course, we all know of some sad cases where we know of dogs that actually have been injured or something and have maybe less than 4 legs. But I'm assuming here that we're talking about a very healthful dog, so a healthy dog. And so, in fact, this statement is true. If an animal does not have 4 legs, then it is not a healthy dog. So that is true. And, of course, the original statement that we started with, the conditional itself, written here, if an animal is a dog, then it has 4 legs. Again, that is true as well. So we see true, false, false, true. Anyway, these conditional statements are some of the most important statements that we'll form in mathematics, and they're the key to unlocking the mysteries that lie ahead. I'll see you soon.